everyone, today we are going to be talking about expanding the unit circle. What we mean by that is with the unit circle we're allowed to find all of the angle measures that are labeled here, but there's also a lot more that go beyond this circle that we can also figure out using what we already know. And so we're going to talk about how do we get these angles that don't actually show up on our circle currently to different points that are on our circle now. Okay, and so what I want you to think about is if I pick any point on my circle, okay, and I'm going to use one of my coordinates, but really I could go anywhere. I could start, say, here at 45. Okay, if I took 45 degrees and I went 360 degrees from this point. Now, when we say 360 degrees, we're typically going counterclockwise. So if I go counterclockwise 360 degrees, I know that's one full rotation around the circle, so I end up back exactly where I started. Okay, and I can do that from 0 to, that one's probably a little easier to see. If I go 360 degrees around, I end up right back where I started. So what that means is that I'm allowed to add 360 degrees as much as I want to any value that I have on my unit circle, and I'm just doing trips around my unit circle and I'm getting back to the same point. By getting back to the same point, the coordinates are staying the same. Okay, so if I take something like the sine of negative 60 is nowhere on this circle. And so what I can do is I can take and add 360 to that angle. And when I do that, I end up getting the sine of 300. Well, 300 is on my circle. It's right down here. And so sine is my y value. So this answer is going to be a negative square root of 3 over 2. Okay, now there's a couple ways to think of this. Okay, I just made the point that going in the counterclockwise direction is considered positive, which means probably going the opposite way, or clockwise, is considered negative. Well, if I consider negative 60, that means I'm going this 60-degree jump, so one short of getting all the way to the quarter, going the other direction. Well, if I think of that, I'm going that same distance up 60 degrees as going down to 300. So I'm going down that 60 degrees is the same as coming all the way around to 300. Okay, hopefully that makes sense. We're allowed to add 360 degrees to go all the way around, and I end up back here at 300, so I take my y coordinate because I'm talking sine, negative square root of 3 over 2. Okay, we can do the same thing with cosine of negative 315. That means I would be going all the way around my circle 315 degrees. You might be able to, clockwise around my circle 315 degrees, which you might figure out where that is. Or what I like to do is just simply add 360 to this. Okay, well, negative 315 plus 360 gives me 45. So this is the cosine of 45 degrees. So I go up here to 45 degrees. I'm at the square root of 2 over 2. Okay, so my answer is square root of 2 over 2, because that's my x coordinate at 45, which we know is the same as negative 315. And we can try tangent of negative 90. Negative 90, again, is not on my circle, but you can think I'm going negative 90 degrees, or I can add 360 to this. When I do that, I'm at tangent of 270, which I don't actually have tangent of 270 labeled here, but if I go straight across my circle, I end up at my undefined up here at 90 degrees. So this is undefined. If I wanted to figure it out, it's going to be my y value divided by my x value, so negative 1 divided by 0 is still undefined. So my answer here is undefined. Just up a little space there, so that one is undefined. Okay, so I can add 360 as much as I want. I get back to where I started. That's kind of the point of all of those. Okay, let's look at something like tangent of 480. Well, the problem here now is adding 360 degrees actually doesn't help me, because if I take my calculator here and I take 480 and I add 360 to it, I'm now at 840, which is even further away from being a part of this circle. So adding 360 doesn't help anymore, but that's going the positive 360 degrees around, counterclockwise. I could also go clockwise 360 degrees, and I end up at the same place. Well, that's that negative direction. So instead of adding 360, I can also subtract 360, and I still end up back at the same place. So if I start at 360, subtract 360, I get 0. I'm back at the same place I started. So I can take 480 here, and I'm going to subtract 360. Well, if I do that, 480 minus 360, I get 120. So this is the same thing as the tangent of 120. So let's figure that out, because that's on our circle. We know how to do that. I go up here to 120. Okay, tangent I don't have labeled over here, so I'm going to go straight across, and I get my tangent is the square root of 3. So I know I have a square root of 3, I just have to worry about my sign. Tangent here in that upper left corner is negative, so this needs to be a negative square root of 3. Okay, how about sine of 420 degrees? Again, too big, so instead of adding 360, I'm going to subtract 360. That takes me from wherever I'm at in my circle, I go counterclockwise, or clockwise one rotation, and I get back to where I started. So I'm going to take 420 and subtract 360, which gives me 60 degrees, so this is the sine of 60. If I go up here to 60, sine is my y-coordinate, so this is the square root of 3 over 2. Over 2. Okay, now let's do cosine of negative 510. Now, negative 510 is kind of unique because it's big, but it's also negative. So what I need to do is I need to get my angle somewhere between 0 and 360 so that I hope it hits one of these points. And so what we're going to do is we're going to take negative 510. Now, right now that's negative, so it's too small. I need to make it bigger. So I'm going to add 360 to that. When I do that, I get negative 150. Well, if we think, is that on our circle? It's not, because these are all positives. So I need to do the same thing again. I'm going to add 360 again. And now I'm at 210. So this is the same thing as cosine of 210. So even though I'm adding 360 once and it didn't work, I can do it again to get me all the way back to where I am on my circle. So cosine of 210, I'm at 210 here. Cosine is my x-coordinate. So this is going to be a negative square root of 3 over 2. And there's your answer. Okay, so I can add 360, I can subtract 360, I can do it multiple times if I need to. If these numbers were so big that doing it subtracting once didn't work, I could subtract again. I'm really trying to basically get to the point where my angle is somewhere between 0 to 360. Those are what I know on my circle. Okay, now this last row here, 7, 8, and 9, look to have those pi's in them. So we're going to switch to radians. Well, with radians, I can do the exact same idea of what I'm doing. We just have to use a different number because it's not 360 radians around the circle. All the way around the circle is 2 pi. So what I'm allowed to do is I can add 2 pi. I can also subtract 2 pi. And my goal is to get somewhere between 0 pi and 2 pi. Okay, so somewhere between those. And now this one's a little bit harder because you are working with some fractions and some pi's, so you do got to be a little bit careful with how we do this. I'm going to use my calculator a little less here. I'm just going to kind of work through these fractions. So let's start with the first one here. Sine of negative 2 pi over 3. Again, I could use my negative direction. I know 2 pi over 3 is up here at 120, so I can go around the bottom here, and I'm probably down here at 240, I think is probably where I'm going to end up. But let's see if we can do that by adding 2 pi. Now, if I just took and tried to add 2 pi here, the problem is I'm adding fractions, and adding fractions I need a common denominator. So I'm going to need this to be over 3. Well, what version of pi over 3 is going to make it 2? That's going to be 6 pi over 3. So I'm adding 6 pi to negative 2 pi. Well, 6 plus a negative 2 is equal to 4. So this is the same thing as sine of 4 pi over that denominator of 3. Well, 4 pi over 3 is down here at 240, so I was in the right spot there. And sine is my y-coordinate, so this is a negative square root of 3 over 2. So same idea as what I was doing with degrees as far as adding and subtracting 360. The only difference is I have to use the correct version of my 2 pi because sometimes it just doesn't work if I don't have that common denominator. Okay, let's try cosine of 8 pi over 3. Now this one is too big because it's positive, and I know it's too big because 8 is bigger than that 6 pi over 3, which is 2 pi that I was just using. So I'm going to go ahead and subtract on this one, and I'm going to subtract that same 6 pi over 3 because that's the version of 2 pi where 3 is my denominator, the same as what I have. So now we do 8 minus 6, which is 2. So this is going to be cosine of 2 pi over 3. Well, I can find that on my circle. Cosine is going to be my x-coordinate. 2 pi over 3 is up here. My x-coordinate is negative 1/2. And that is my answer. Okay, we can also do tangents. Here I have 13 pi over 2. This one's over 2, so I need to figure out 2 pi over 2 is going to be 4 pi, because 4 divided by 2 is 2. So 4 pi over 2 is what I'm subtracting. If I take that away, 13 minus 4 gives me 9. So this is 9 pi over 2. But that's still too much, so I'm going to take away another 4. pi over 2, which gives me 5 pi over 2. Still too much, because even over 2, my highest one I have is 3. So let's go ahead and go again. I'm going to subtract another 4 pi over 2, which leaves me with 1 pi over 2, or simply pi over 2. So 1 pi over 2 is up here at the top. I have this one labeled for tangent as undefined, so my answer here is undefined. Okay, so hopefully that's making sense with radians and degrees. As far as moving around my circle, I can go beyond what I actually have just simply by adding and subtracting one time around the circle, either the 360 or the 2 pi. And my goal is always to get between 0 and 360, or between 0 and 2 pi. Next thing here, let's convert the following from degrees to radians. So I'm giving you this degree measure. I want to know what is 45 degrees in radians. Well, the easiest thing to do is just look at your circle. If I go to 45 degrees, what is my radian measure at that point? Well, it's pi over 4. So my answer here is simply pi over 4. And do the same thing with 225. Down here at 225, my radian measure is 5 pi over 4. My last one is going to be 330, which is over here, which is 11 pi over 6. This is all part of that one. Sorry, 11 pi over 6. So that is my radian measure. I can also go the other direction. I can convert from radians to degrees. To do that, I have 3 pi over 2. So if I go on my circle, 3 pi over 2 is down here at the bottom. My degree measure is 270. There's my answer. 14. 7 pi over 6 is, let's see over here, 7 pi over 6, so I go, my degree measure is 210. And finally, pi over 2 is up here at the top, degree measure 90. Okay, so those ones should be pretty quick. Those ones shouldn't take too long. Just simply using your circle to see where are we the same with that radian measure and the degree measure, or vice versa. Okay, so big thing for today again is just expanding the unit circle, talking about how we can go beyond just the angles that we have here and go above 360 or below 0 with those negatives.